Hello, my name is Mateo Torres Chapa, and for my final, I will be covering the Messinian salinity crisis. Here's a quick overview of my slides if you feel free to pause and take a look. So, how did the Messinian salinity crisis, or the MSC, begin? During the late Miocene epoch, roughly 6 million years ago, there were changes in the Earth's crust, specifically converging African and Eurasian plates. There was uplift in the Betek Rif mountain range, which connects the southern part of Spain and northern Morocco. This uplift would happen repeatedly and progressively, not just in one fell swoop. The belt would continue to rise and narrow the corridors that connect the Mediterranean to the Atlantic and eventually blocking water inflow. This main marine inlet is what we know as the Strait of Gibraltar. And over time, this uplift led to the basin becoming completely isolated and restricted from the global oceans. This disconnection was a critical trigger for the MSC, as without a steady and reliable source of incoming seawater, the high evaporation rates in the Mediterranean became unsustainable, setting up for an extreme transformation in the region. Now that the basin was completely isolated from the oceans, evaporation rates, like I mentioned, greatly exceeded the limited inflow that was now only coming from rivers and rainfall runoff. Sea levels inside the Mediterranean dropped rapidly by a few hundred meters and even exposed the seafloor in large chunks. Some of the new formations that were found include shallow brine pools, hypersaline lakes, salt flats, and even completely dry basins. Naturally, this changed habitat had an effect on the fauna of the area. The Mediterranean became inhabitable. Animals either migrated away or died off over the generations, and the remaining bodies of water were either too salty or too shallow, making it difficult for marine organisms to survive. These conditions are also produce massive deposits of evaporites, which are sedimentary rocks formed when water evaporates from a saline solution, leaving behind a mineral deposit. These deposits were mostly made of halite and gypsum, and the longer there was a presence of salt water in a certain area, the thicker the layers of deposits would be. Some of the thinner layers are found in Spain and Italy, generally being from tens to even hundreds of meters thick. But even the largest deposits are found in deep basins, which each layer can be as thick as 1,500 meters to even 3 kilometers thick. Evidence for the MSC is supported by several geological sources. For starters, deep sea drilling cores collected from the Mediterranean demonstrate thick sequences of evaporites, as I already mentioned. These formed when the salinity levels reach far higher in the oceans in the Mediterranean than other oceans tend to be. These cores are important as they demonstrate a repeated cycle of major water loss, as well as being the most definitive piece of evidence as a modern ocean cannot produce kilometers upon kilometers of salt. And another piece of evidence, of compelling evidence, comes from erosion. Data from seismic reflection surveys reveal that giant river canyons that are buried beneath today's seafloor and other younger sediments in the Mediterranean, indicating that they would flow into a much deeper basin. This could have only formed so deep if the Mediterranean dropped more than a kilometer in certain places. Lastly, taking a look at the fossil record, marine fossils showed to decline greatly during the crisis, with some areas even showing gaps. The fossils that were present include halophiles, organisms that thrive in high salt concentrations. There's also evidence of transitional zones in which some terrestrial organisms appear, pointing towards the theory that shorelines change over time with the occasional exposure to the seafloor. All of these show us that the Mediterranean underwent great geological change and also ecological stress. The MSC ended as dramatically as it started, around 5.33 million years ago. The combination of tectonic and erosional processes breached and reopened the Strait of Gibraltar, reconnecting the Mediterranean to the oceans. What started as a small stream eventually carved open and turned into a powerful megaflood that surged salt water back into the basin, known as the Zanclean Flood. Considered to be one of the largest floods in Earth's history, it is estimated that the Zanclean flood occurred merely over a couple of months or even 2 years, which is extremely quick considering that the MSC lasted around 600,000 years. Also to mention, the speed and the force of the water from this catastrophic flood was powerful enough to carve out deep channels and fill the basin. This flooding event abruptly ended the MSC and was able to restore marine conditions back to normal almost immediately, restoring the Mediterranean to global ocean circulation. So why does this event matter geologically? The MSC is important as it shows us how delicate our planet is and how sensitive bodies of water are to tectonic activity, even ones as large as the Mediterranean Sea. We are left with gigantic evaporite deposits that help us understand how this event affected and will continue to influence the Mediterranean region. And we also have the Zanclean flood to thank for providing one of the best examples of naturally occurring megafloods like the ones described in ancient mythology and religion. This period in the crisis stands as one of the most clear examples of how the Earth's systems are all interconnected and how delicate our planet really is to great changes. And here is my works cited.